So without further ado, we're coming up on 8 o'clock and the main event is at hand. So we've got Erik and Elio that are going to do some crossfire counterpoint stuff on a few items, and there are no rules or guardrails on this situation. So we're just going to give a little bit of frame it up. But so if Erik is ready to go.
I am ready.
Okay. So let me.
Gotta play the intro music, John, you know?
Yeah, need something, some kind of fancy graphics where
That's
things
right.
explode.
Are you ready to rumble?
There you go.
Let's get ready to rumble.
Well, the question I came up with are password managers, yes or no. I think there's case to be made either way. I think a lot of people struggle with that. And either way, there's pros and cons. So what's the answer? Password managers, yes or no? Elio, take it away.
Yes for now. Hopefully we don't need them in the future. So it's real simple. That's at this point, password reuse is a much, much, much bigger problem than lack of good passwords. As a side note for anyone who's building password-based systems, there are libraries that will calculate the Shannon entropy of the password, which is what you actually care about, not how many weird characters and finger gymnastics your users are doing, because if you make it hard, they're going to take shortcuts and make it worse. But passwords just are never going to work. There's no way passwords ever work, because what you need is you need a large key space. You need a lot of entropy, which means it's impossible to remember. And so we have a system that literally can't possibly work, because the machines need one thing, the humans need another thing. And so we need to replace it with actual digital identity. And this is what I call, my terminology, is the original sin of the internet. Is we built all these systems, and a lot of them, I got to actually meet, what's his name, gentleman who did DNS and SMTP. And this was at a conference here in town about 4 or 5 years ago. And he was saying, during his talk, how did they choose you to write DNS? It's like the most important service of the internet. And he's like, well, all of the engineers at the lab were kind of busy with other stuff. And they're like, well, throw the intern on it. Like, no, who cares? This isn't going to go anywhere. It's crazy research. Let the intern come up with something. And that's how we ended up with DNS. And the problem is most of the systems that we have today, that's about how they came out, is they just kind of organically grew. And organic is being a little generous here. People were just kind of thrown on projects, and whoops, suddenly the entire world is using. This is why we had to move to IPv6, which we're still kind of trying to do. Turns out we thought we picked a big enough number. Whoops, we didn't. So we need to actually build a system. This is crazy how much of the web and how much of computing is just basically a huge collection of nasty little hacks, that it's shocking that it ever works. And the more you start digging into computer architecture, how many people here know that floating point, I wish we could do show of hands. There's kind of a way to do that. Do you know that if you do 0.2 plus 0.3, what do you get? Anyone want to unmute and answer?
0.
You usually get a whole bunch of weird decimal places. And it actually depends on the number, and it depends on the language. So, and I think I misspoke. It was 0.1 plus 0.2 should be 0.3, obviously. And it's actually in many languages that use the IEEE floating point, it's 0.3000. I can't remember how many zeros, and a 4. And there's actually a website that will show you which languages do which thing in which case. And so that's a weird little edge case that has actually bitten people in the real world, because when you're doing math, you're expecting computers really good at math, right? Kinda, depending on what kind of math you're doing. So there's all these little sharp edges that we have, and identity is one of them. And everything you see right now, everything out there you see where you have phishing, you have all these attacks. Why is that so hard for us to get that right and not click on the wrong link? Because you have no idea where that's coming from. We have the tools, we have the cryptography, we have GPG and PGP going back to the 80s, but those are too hard to use. And just like the last gentleman was saying, you want people, it has to be easy for them to use. If you give them something, even if it's really good, they're not going to use it if it's not easy enough to use. And we've done a terrible job making this stuff accessible, so no one uses identity. So we don't have identity. When that email comes in, you put whatever you want in the subject line. literally whatever you want. And there's a little bit more security today, and we have some different layers of security, SPF, DMARC, all this kind of stuff that kind of sort of works some of the time, but it's not as good as actually just having a GPG key and you send a message and you just sign it, and the crypto's solid, and you know exactly, as long as that key wasn't compromised, you know exactly who that came from. And then if you start playing with Web of Trust, you could say, wait a minute, who is this person? It's just like in the street, some random person comes up to you and starts acting all buddy-buddy. Who are you? Why are you talking to me? Like, there are ways of dealing with this stuff in the real world. And the problem is we don't have the systems out there. There are missing, like, huge gaps of functionality missing from today's systems that if they were out there, it would be pretty trivial for us to deal with these threats. But because these pieces are missing, it's almost impossible. And we keep just layering more and more and more complex stuff on top, trying to make it better. And as everyone here should be keenly aware, complexity is the enemy of security. We're digging the hole a lot deeper and we're making it worse. So I'm going to leave it at that. See what Erik has to say.
Wow, that was quite a bit of an answer. I wasn't expecting that. So password managers, I would say I lean towards yes. I would not say it's necessarily for everyone. However, I think most people would benefit from it. It has to be a password manager that is properly designed and architected. That's why I put that little caveat in there. I've met many of them that are not very well designed and they don't integrate well. However, I also have parents that are of such an age now where, you know, their idea of a good password is, you know, their last name and, you know, 4 or 5 numbers, maybe if I'm lucky. So having a nice password manager for them and getting it installed for them and having it do automated and have it automatically create strong passwords for them in the background that are 24 plus characters, but they never see it, so what do they care? That's a wonderful thing. And the fact that many of them now are cross-platform, so it doesn't matter whether they're on, you know, the Windows Portable or they're on their phone or whatever, the password gets used and you don't have to worry about it, is a wonderful thing. Some of the vendors actually out there now have, you know, family quote unquote subscriptions to where, you know, I can own the subscription but take care of the parents, take care of the kids and things like that to make sure that they are, you know, installed, they are being used in the proper way. So that helps tremendously. That said, do I think passwords are going away? Not in the near future. I think I will probably be in the ground before they go truly away. One is it's one of those legacy items that we're not going to get away from easily. I mean, just look how long other legacy items have held on here. Even if you just narrow it to just talking about operating systems, my God, I still see people running Windows XP, and the reason for it they give me is it runs. Why should I change? You know, and I can't argue with them on some occasions like that because they're right. And if it's, you know, on an isolated box sitting in a corner that ever only runs one function, great, that may just do just fine. But when it breaks, they're going to be in for a lot of pain. As a matter of fact, I went to a federal agency back in Washington, D.C. one time, and we were getting badged in, and I kept looking at the guard behind the bulletproof glass with all of our IDs, and he was typing information in. I kept staring at the machine he was typing into, and finally our escort came over and said, "What are you looking at?" I'm like, I swear to God, that looks like an IBM AT. And I started moving around to where I could kind of sort of see the screen, which, by the way, with feds, they don't like that, made them very nervous. And I had to scream, "Oh my God, you're using DOS." This was about 7 years ago, and they were literally still using DOS. I think it was DOS 5. But it's one of those things. Why were they using it? Because it worked. So legacy has this nasty habit of hanging on longer than we want. Now, what are we going to move to? The idea of everyone, just like your social security number, which, you know, isn't used for identification, but is, everyone having a nice crypto key, and that is your ID, your digital identity, that would be great. Then we get to the other side of the coin. And the other side of the coin is sometimes I don't want to have to use that identity because maybe I don't want what I'm doing, and not for illegal purposes, but maybe I don't want what I'm doing to be tied back to that formal identity. Let's talk about medical things. You know, oh my God, I think I've been exposed to, pick your favorite sexual disease, and I need to get tested, but I don't want it to come back on me. Would you avoid testing if you knew it was going to come back instead of going and getting tested? So there's some weird things that happen like that. Would it stop people from reporting crimes, potentially if they knew it was 100% traceable back to them? And again, people go, well, why would you not want to, report crimes? Well, we live in a world where if somebody finds out that you've reported a crime against one of their friends, you could become a victim of a crime. So there are reasons to have or need, and I'm going to say anonymity, but still, be able to do things. And that's going to mean that you're not going to have digital signatures or, because what's going to happen with digital signatures is right now, if you get a digital signature today in the United States, it's legally binding. So if you have a VP of a company or let me say the CEO of a company, and he's got a digital signature, and I get a hold of his digital key, and I go off and say, sign a document that says, I have sold the company to the Erik Graham for the sum of $1. Technically, in the United States, that's a legal and binding document. Now, is it going to get challenged in court? Yes. Am I really going to get to keep the company? Probably not. But is it going to be a hell of a fight? Yes, it is. So again, digital signatures, love the idea, but I think you're always going to have an alternative to it. And as long as you always have an alternative to it, you're going to have challenges. Passwords, in my mind, are not going to go away anytime soon. And then again, when we get back to the digital signature things, one of the arguments you see that happens, because every couple of years we start talking about digital signatures and how, the post office could be the issuer of federal IDs, and immediately what happens is people spin up and going, now the government's going to track everyone everywhere doing everything. Not that they're not doing that already, but I mean, it gets emphasized and people get fired up over it. So again, I think it's something that there are changes that need to happen. I don't know that I'm going to see them in my lifetime. I think it's going to take a much longer time, and it's going to have to go through some iterations. It's kind of like biometrics. Everyone was thinking biometrics is a solution to everything, which I always laughed about, because what biometric? And I had people go, well, we're going to use thumbprints because we think that, everyone will accept that. And I said, great. I have a gentleman I work with who is a paraplegic. He can't move his hands and arms. So what is he going to do? Oh, well, we'll have to do a different biometric for him to log in. Let's do facial recognition. I'm like, good. Find me a company that does both of those in one package. And the answer is, and you still today have a hard time doing that. Matter of fact, when I did the research 7 years ago, I still couldn't find any one. Okay, it's one or the other, and stacking them up, they don't play well with each other.
Let's talk about the bigger issue there, though. When you talk about biometrics, two things. One, biometrics are usernames, never passwords. You cannot cancel a biometric. Well, you can cancel a biometric. You probably don't want to. You're kind of stuck with your fingerprints. You're stuck with your face. Again, probably don't want to make drastic changes to those. So that's an issue. The other thing you run into when we're talking about passwords and other types of authentication, the one thing that's really, really nice about passwords and cryptographic keys is that they're binary. You either get it 100% right or it's 100% wrong. It's not close enough. But the problem with biometrics is you're taking measurements from the real world and people's voice change. My voice changes, is sounding different right now. If you record me when I wake up in the morning, it's going to be a different sound to my voice than right now. If I'm out hiking and I get dehydrated, there's going to be a very different sound. So voice prints change. If you get sick, if you get, stung by a bee, you have your face can be all swollen up. There's every biometric you can think of varies over time. So what you end up having to do is like a fuzz factor. You end up having to have a margin of error. And so as you stack them, that margin of error compounds. And so it actually, in some ways, gets a lot easier to fool a biometric because I don't have to be 100% right. I have to be close enough. And if you look at the lighting angle, look at what Apple went through with Face ID, with all the different lighting. Is the sun coming on your face? The phone is here, or is the sun behind you and the phone is trying to take a picture of your face? And they tried to get around that with the little dot projector, little IR dot projector, so they get a depth field. And they tried to do some other stuff, but they still had issues. Not to mention all the ML issues and the training sets and all that kind of stuff, where when they first released Face ID, I don't remember if everyone remembers, if you were Asian, pretty much everyone looked the same. They forgot to put enough training data for Asian faces in Face ID. And it's one of the better facial recognition, like consumer grade ones out there. And it was terrible. So that's a major problem that people forget. When you go biometric, besides the non-cancelability, then you have this whole issue of this fuzz factor. And when you start looking at, well, what's the probability that's the right person? That's a huge detriment right there. Like you've just downgraded that security dramatically. And so that brings us back to passwords. And fundamentally, what is a password? A password is a really crappy key. And if you want me to do a screen share, there's a KeyPass X actually has a nice little generator that will estimate the entropy, the Shannon entropy of a password. And you can actually see how strong is this. And most of the passwords most people are going to use, if you look at cryptographic keys today, 128-bit is standard for symmetric. And now that quantum computing maybe will be out in the next 20 years, people are, because of Grover's algorithm, doubling that to 256-bit. That's a really long password. And ideally, every one of those bits should be high entropy. Because if they're not high entropy, like in a password, because language is made of patterns, thus low entropy, then only the bits that are actually entropy are really worth anything. Otherwise, it's really easy to break it. So we're basically looking at just crappy key management. So what we have now, we do have key management. We do have kind of what you're talking about, but it's like the worst possible version. It's one where the math doesn't actually work out. But the problem is, like you said before, Eric, does it work? And people are used to this. Like when the internet came up, I remember when I first did my first few businesses, I tried to convince people, like, this is back in the 90s, like, hey, I can make a website for you. And I would have people look at me straight in the face and be like, a what? What do I, like, who cares? Why would I want that? Who cares what a website is? No one's using those. And
Eric, sorry to interrupt it, but just for the record, we're at about 16 minutes on this one topic. So actually, I think this is great. We got you guys going. If we want to go through the other questions and kind of time box it, we're willing to do that. I think
lead the show, John.
I think the last question is going to play into both what you're talking about. So maybe those would be some more time to kind of cover more of that on the tail end. So,
all right. Anything you have, Eric?
So let me wrap up two thoughts on this question that we sprawled all over, and then we'll go to the next one. You know, this is why using a password manager where I have strong authentication to the password manager helps. Now I'm giving them one password to remember, a second factor, whether it be, you know, the biometric, you know, the thumbprint or dialing the phone and getting a code, giving them a two-factor authentication on it that unlocks something that is giving them a lot better passwords. Like I said, most of them that I've configured are 20 plus characters, totally arbitrary gibberish. So it's not gonna, and they're all different. I never allow reuse for those arbitrary passwords. So, you know, I'm hiding the complexity but I'm still putting in a fairly strong front end. And it, to me, it is this is how I'm gonna play the game and buy time in the arms race that is authentication.
Yeah, imagine if that was fully properly integrated and instead of a 20-character password, you had 256-bit keys. Like I said, we're slowly being forced into where we need to be. And this idea of what works is not working. If it was working, we wouldn't be having breaches on the news like 4 a day at this point. Like, it's not working. So we have to finally fill this gap in. We need an identity protocol. And going back to some of the stuff you were saying earlier, it needs to be self-sovereign. And that's a whole nother talk we'll have to do sometime. LaTanya Sweeney's research, phenomenal work on recorrelational attacks. And even if you don't want people to track you, it's actually really, really easy. With the amount of data out there, it's really, really easy. Even if you're not putting cryptographic keys on everything, there's so much to work with to correlate who's doing what and where you are, that it is almost impossible to stay hidden anymore. But that's a whole other topic. So we'll stop there.
Cool.
Give us the next one.
All right. So this should be easy, but I say that. Should home users encrypt their hard drives? These are people that don't have IT support resources and that are just your average Joe.
You know, even if you don't, with all the ransomware, someone else will do it for you.
So my take on this is yes, encrypt it. I'm not saying use any fancy encryption. BitLocker is fine. And the only reason I would say to encrypt it is because people do such a horrendous job of getting rid of their equipment. I used to, long story short, I used to go down to the ASU salvage yard when they still had it in Tempe and pick up hardware, to use in my own home lab that came out of ASU. And I never met one piece of equipment that had been wiped correctly. And it was amazing the information I would find on them. So
Hey, even NASA
gold
didn't.
mine.
Even NASA, there was one of those where they had data that was worth $250,000. So if NASA's not doing it right, I doubt the home
They
users
watch
are.
it.
Was that your fault, Rich?
No, just my customer.
So have
Sorry.
you guys ever dealt with anybody who's lost their encryption key to their encrypted hard drive?
Not dealt with, but I've met 2 people at DWeb, one of whom had used a really good password to encrypt a, I think it was Bitcoin. It was some cryptocurrency. And one of them, it was like a 30 or 40 character password, just random generated. And I think that one was like, it was a few $100,000 worth of Bitcoin. And then the other one lost a hard drive, and there was a similar case on the news where, yeah, they lost the hard drive. They didn't have the actual key anymore. And that one was over 2 million in Bitcoin. So there are downsides to encryption. But I agree with Eric that the other thing people forget about, where are the hard drives and solid state drives? Like everyone, we're talking about your computer, right? And probably your phone. What about your printer? What about, any other devices? Everything now, all these voice assistants have drives in them. Are they properly encrypted? And when you throw those out, or if you just buy them secondhand, then how hard is it going to be to pull the data off those? So I think there is a trade-off there in terms of getting your data back. Like there's a new risk there. If you can't remember your key, if you don't manage your passwords well, you have a big problem now, because you can't get your data back. Mom and pop and just grandma and grandpa can lose all the pictures of the grandkids because they encrypted the drive and they just never had to type it in. The computer automatically reboots, and it just, I've seen that where certain OSs will keep keys resident, and as long as the thing never turns off, you hardly ever have to type in the password. Like, do you have it somewhere? Do you remember it? Probably not. Now everything's lost. But at the same time, like Eric said, when you get rid of that and decommission it, there's so much data that can leak, and who knows where. We've had really interesting cases of people buying devices and tearing them down, and just in some cases just plugging them in. And if it's not encrypted, like who knows where that's going to end up.
Yeah, so, I have had people come to me that did cutesy things with encryption, like put their key on a individual, I'm worried about the government type of thing. So his key to undo the encryption was on an SD card that he plugged into the front. That way he could grab it and swallow it. Don't ask me. I really didn't want to know more than that. But because he had done that, one day that SD card was no longer readable. So guess what? His machine was gone. Now, could he have stopped that? Sure. You just simply back up the SD card to another SD card or whatever. But he hadn't thought of that. Who would think that an SD card fails? And I'm like, solid state stuff does fail, just like spinning platters. So, encryption is a wonderful thing when used properly. And therein lies the rub, is it has to be used properly. And for everyone that I've set it up for, I put it transparent in the background, like I said, BitLocker, and it's only to protect that device for when it goes out to salvage, or they give it away to somebody, or, Goodwill picks it up, or anything like that. But another good point you brought up was, other devices other than, I talked about PCs, but yeah, you go on eBay, you can buy all kinds of interesting things, firewalls, all RAID arrays, because RAID arrays, there's no, often, I won't say always, often there's no easy, wipe function.
Well,
oftentimes people won't wipe them.
With RAID, though, you do have the benefit that if you have more than a few disks, if you're, doing 5 or 6 certain levels, it's going to scramble stuff and make it not impossible, but harder to get the data back. So that's nice there.
Except when you buy all the drives with the device. and
yeah,
and
you leave them in there.
And most RAID is smart enough now that if you mix up the drives, because I played this game one day, mixed up all the drives in a small NAS, it was like, hey, idiot, you moved your drives, but that's okay. I'll put it back together for you. So thank you very much.
Convenience. But yeah, the other thing is like light bulbs. There was that famous hack where
Yes.
the Philips Hue light bulb, you could actually get in to someone's network. Well, a different hack is if you throw that thing out and you throw up, what is it, a little JTAG connector, you can probably pull the network key out of that light bulb. But you'd say, okay, well, if I find a light bulb at the dump though, and I pull the key, who cares? Well, you probably also have the BSS ID, and you can use any one of the 3 or 4 databases that will actually tell you where on the planet that SSID or BSSID is. So you have everything you need now.
Yep.
So it's a huge problem.
Yeah, and I see in the chat, Richard pointed out tablets, and yeah, tablets are another big problem. I see that all the time where people, well, I didn't do this or that type of wipe, and yeah, their data's still on it. And I do agree with Richard. The true answer is thermite, just melt it into the ground.
That's what I thought you were going after.
Yeah, I had a friend's dad get sent to jail because his PC ended up at a data doctor's, and he had porn on it.
Oh wow! I'm guessing there's another descriptor there, but yes, wow. Yeah, no, it's people don't. Part of this, I will say though, before we get off this topic, part of why are people so reluctant to encrypt is that, again, you risk losing data. And one of the other missing gaps in security, and well, computing, not security, but just computing in general, is backup. Backing up is a pain in the butt. Like, it's 2020. Why do we not have computer systems that can manage where the data is somewhat automatically? This should not be that hard. And yet it is. It's a really, really difficult thing. Like, I run backups, but I put a lot of work into my backups and rotating disks and how many disks do I have? And it's a real pain in the butt, especially since ransomware, because now you want to make sure that if you have somewhat of a immutable backup. So if you do get hit by something and it gets through all your defenses, you don't want to be overwriting the old backups. You want some lag. You want to be able to find the stuff that's not encrypted. So yeah, like we're just missing a lot of pieces to the ecosystem. And until we fix that, until we make it, not just add them in, but make them easy enough where normal people use them by default, we're going to have people making, quote, bad decisions that are actually rational and reasonable decisions, where they're just weighing the threats differently. They're like, well, I'd rather not lose my data. I'd rather be able to go to, drive savers, data doctors, whatever, and get this drive recovered if it fails, because I don't have backups. And so it'll be a lot easier if I don't encrypt it, which is a valid solution depending on your threat model.
I've got to chime in here, and I agree with you 100% that what's missing is a good backup solution for, one button, press it and do a backup, and then again, remove the backup device from the machine. We have gotten out of the habit. I remember the early days of computers where everyone had little tape backup systems sitting there whirring every night to back up your data, all 40 megabytes of it. We don't have those really anymore. And where people are backing up, as you pointed out, they're doing another attached, portable USB hard drive, which again, in a ransomware attack, isn't going to save them at all. So what they need is we need a way for people to understand. You plug this drive in, you press the backup button on the operating system, it backs up, then you unplug the drive and the drive goes, 50 feet away from your computer or something. Don't touch it. And you do that on a regular basis.
Well, that's the key, Eric. You got to disconnect the backup from the computer.
Well, you do in today's world, Rich. I mean, the other issue you run into is if you had proper immutable data stores. So this is the thing, like a lot of people I'm sure would chime in with, oh, do cloud backups, then you won't lose the drive. Okay, but if you do a cloud backup, you're still potentially at risk. I know some of them are now versioning data and kind of doing immutable stuff where if you lose it, you're not screwed and they can rewind for you. But then again, that cloud company is now at risk of a ransomware attack. So that's another way to lose that data. So I always tell people, look, so I have a whole speech I haven't given for a few years. I got to dust it off, update it a little bit, and give it again. And it's disaster recovery for individuals and small businesses. And we talk about the rule of threes. If you give a crap about your data, the minimum number is 3 copies. you must have at least 3 copies of that data if you care at all. If you care a lot, you should have like 5, 10, however many copies you need, depending on your, again, threat and risk model. But right now, you know, everyone's just throwing it in the cloud. Well, I'll just do iCloud backup, or I'll do, you know, choose your favorite cloud provider. And the stuff you were mentioning earlier, what I wanted to chime in on, you know, we have all these hacks. There have been, what was the 911 outage? There was the Tokyo Stock Exchange outage. There have been a ton of outages in the last week that were not attacks. And I just, oh, it drives me friggin' nuts. You see these people going on the news and they're like, well, it wasn't a hack. We didn't get attacked. Someone just pushed a bad configuration. That's terrifying. I wish it was a hack, because if it was a hack, you could say, oh, those bastards from whatever country you want to choose for your bad guy, they got us good. They're pretty sharp. They got us. We'll do better next time. When it was just a failure where you pushed a bad update or you pushed a bad config, or in the case of the Tokyo stock market, one piece of equipment failed, that's terrifying. You're like, oh my God, the people that put this thing together are grossly negligent. How can one device bring down a $6 trillion market? You cannot tell me.
It's called BGP.
Yeah. Speaking of holes. So it's insane. Like, to me, that's much more terrifying. And this is the problem, is when you trust other people doing services, do they know what they're doing? So I think the future here, because someone asked privately, do you think there's an 2020 to 2025 solution? So next 5 years, what's the solution? And I would say, I don't know if it'll happen in the next 5 years, but some of the research on some of the distributed technologies, like DAT, like IPFS, there's several others. There's actually about a few dozen of these. It's really interesting. And having systems that can distribute data, because it shouldn't be backup. Backups that are offline are a pain in the butt, and those can get lost. They can get lost in a move. They can get destroyed in a fire. There's issues with having to store the backups yourself. Like, we have all these computers. Why do we not have a system to manage where the data is and who needs access? Because what most people fail to realize, even most corporate things, most data has multiple parties that need access to that data at any given time. This idea of single ownership of data and having this like taxonomy based, like this person, this org owns through this chain of people, this data, is absurd. It doesn't match the real world. Normally it's groups of people that have data that's shared that all need access, and those groups change over time. So at some point, maybe we'll have that, and then things will get a lot better. And if that's built in a way where you have some immutability built in or some snapshotting, then ransomware, all this other stuff won't be a big deal, because you'll be able to, you know, look at any one of 20 or 50 or 100 computers that this data's on, and you'll be able to rewind and get what you need. And when that's the only way it's going to work, when you don't have to think about it at all. When you put it in a computing system, is just there and safe, and you can ask the system, how safe is this data? How many copies and where are they on the planet of this data? That's the system I want to see. And we have the tech to do that. We have had it for at least 30 to 40 years. So someday, when we're tired of how this works, we'll build it.
Respectfully give you the ding or whatever. We're at 31 minutes. So you guys aren't helping me out. We got to find some things you guys disagree on. See, that's the key.
Well, I had a whole bunch of stuff about our users stupid, and is that their fault security is awful. That's the one I think we're going to really have some fun
All right.
with.
Well, either that, or we can talk about agile development, and either one of those will get us started.
Nah, I don't think we disagree on that one.
So the next thing we had on the list is, and I think this is an interesting question, can Google do a better job at protecting my info than I can?
Oh, I got to jump in on this one because Google is my
You
friend
first.
right now. So
Go for it.
the answer is they fix one problem but open up another. So can Google protect your data? Google on the back end can protect your data very well. The problem is not the back end, it still is you on the front end. If you don't configure the services correctly, if you don't do the right things that lead into Google services, you haven't done anything for your security. You just moved it. Instead of it sitting on your system, you've moved it into the cloud. It doesn't help you. It's kind of like the whole S3, buckets that we keep seeing people getting into and stealing volumes of data. It's not that S3 is insecure. It's that the configuration of it that somebody was put in charge of didn't configure it securely, put it out publicly, bang, the data is now all over the globe. So
it's a little both. I mean, it's primarily what you're saying, but there have been data loss incidents, not with Amazon, but Microsoft had one where they lost this whole huge database, and the only reason they got any of it back was it was on some big fancy, I think, Sun array or something that had like really, really good redundancy, and then they were able to bring in the engineers and spend like a week reconstructing it. And that's the problem, is it's partly what you're saying. Are you configuring it right? And again, it should be secure by default, not just open to the world by default, but usability always wins. You get more customers. Oh, look how easy it is. I can access my data from anywhere, and so can everyone else. The other issue is, what's your threat model? So if you're saying, can Google protect my data? Well, if part of what I consider protecting my data is not having all my personal data rifled through and monetized and sold to advertisers, they could, except their entire business model is the opposite of that.
So I'm going to chime in just because I've got to, because that depends on the service and who you are. If you are using Gmail for free, you're right. They own you. They're going to take everything they want. In the business world, though, they don't do that. So there is a difference.
Well, that changes over time. I will say, kind of in the business world, but TOS, how many updates have you seen where TOS terms change pretty dramatically? And there's no way for you to actually like meaningfully opt out and say, no, like we agreed to this. You can't just change it. And I agree, in the business world, you have a little more leeway where they're going to have to actually get you to sign off on a contract. So I don't think it's impossible, but I think you're right. It's less likely that that kind of shenanigans are going to happen in the business world. But as far as consumers go, TOS changes constantly, and some of those are super malicious. So just because it's good today, if they can make more money, if they, if they're getting a little strapped for cash and there's a way they can sell more of your data to, get that bottom line looking a little better for the next shareholder meeting, they're going to do it. That TOS is going to update. You're probably not even going to notice. You're going to get some little message you click away because it's the fifth one you've gotten when you logged in. And then there you're right back with someone rifling through all your data. And it might not be them. It might be, we've seen DMVs selling data, as a horrible example, to data brokers. And so it's not that the DMV is digging through your data, it's that they sold it to make a few extra bucks. And now who the heck knows? And who knows where that data broker is going to sell the data, how many times that's going to get sold. So keeping your data private at this point is extremely difficult, if possible.
So let's separate two functions here: secure versus privacy. Google as a whole is going to keep it secure. If you secure the front end, it's going to be secure. I have great confidence in that. Having played with it, torn it apart, attacked them in meetings, I'm confident that Google has got a robust security solution. The privacy aspect of it is a whole nother ball of wax, especially when you leave the non-business, the non-commercial, where you're not paying for it. And you can say this of any cloud or any service out there, whether it be Facebook, LinkedIn, whatever. If you're putting data into it and you're getting a system for free, you are having your data perused through.
But that's the problem, is even if you are paying, in some cases, that happens anyway. And I will push back just a little bit, though, on, so your whole thing about Google, it'll be secure if you do everything, if you configure your part right. I would say for the most part, but with any big org, the people who are part of that org change. Even the military, look at Snowden. Even if you do a super in-depth, top secret SCI clearance, you don't always get it right. You have people that flip for whatever reason. And so look at the Twitter hack that happened with the whole Bitcoin scam. Was that just a month ago or two? And all you need is one insider having worked at Amazon in some of these places. Like, we all know there's like one dude, actually a whole team of dudes usually, who all have access to all of the data, who can log in and impersonate anyone. And everyone was horrified that, oh my God, how come one employee can impersonate anyone on Twitter? Because they're an admin. Because if you're going to have someone administer the database, there's no real way not to do that right now. So I will agree with you. So far, we've only seen the Twitter one's the only really good example that's been publicized that I can think of. But one insider, man, that's all it takes.
Well, I think if you had that on any of the big three cloud providers, Azure, AWS, or Google, that's extinction level event. If they had something like that, they would be gone. People would flee them so quick, the boat would sink like a rock. So I believe
Twitter's not dead.
Well, Twitter's not, in my opinion, Twitter is a SaaS, if you will. It's not necessarily a cloud provider like we put Google and Azure and AWS into that bucket. I don't think they're in the same bucket.
I will push back. I want to agree with you. I want to, but I don't think that's how it actually works out. So take AWS, for instance. There's so much lock-in. All their little protocols, all their, 350,000 services, whatever the hell the number's up to now. They have like 6 or 12 different database systems. They have all these redundant services that are all totally unique that you can't run on other VPSs. And so even if you've built all your stuff on AWS, all your people are AWS certified, and you're going to try to move to a competitor to Google Compute Cloud, are you kidding me? Do you know how much that's going to cost? You're going to have to, it doesn't matter how bad the attack was. You're stuck there, man, or you're going out of business. You're not going to be able to jump ship.
Well, let's talk about, that's a whole different problem that unfortunately I don't feel management.
It is, but it's also why what you're saying, like in theory, economically, that should keep them, make sure that they're not going to screw up. But in reality, that's not actually a safety net.
I agree, but again, so let me back up a little bit. So this is why we have contracts and things like that, because at the end of the day, if I can't jump ship, first of all, if I want to go back even further, if you lock yourself in that tight to a vendor, if you're vendor locked, you deserve what you get. That's my personal opinion. Never vendor lock. Never use a function that you go, my God, they're the only one on planet Earth that does this, like certain databases. If you do that, you're vendor locked, you're going to get bit at some point in your life, probably.
I agree with you, but that's the reality is most people do that. Have you seen how much AWS training and certs are out there? Most people are vendor locked to AWS.
People vendor lock, absolutely, but that's because they don't understand the problem until they get bit by it. Again, most of these clouds that we're talking about, whether it be Azure, AWS, Google, where they get bit is when they start looking at the bills. At the end of the year, when somebody goes, okay, budget, we're going to do budgets. Oh, what do you mean our cloud services now need $100 million a year? We're spending more than we spent when we had all of our own data centers and on-prem. Matter of fact, it's a lot more.
We only took out 1 gig from Glacier. How come we owe $100,000? Sorry, I'm exaggerating, but it's insane.
Exactly. What happened? Why didn't we know? It's because that's where you get, that's usually what triggers people to go, why are we vendor locked? It's not worried about, security. It's the, oh my God, we just got the price tag because we didn't listen to anybody.
Yeah.
So
the problem is, though, you have a lot of people getting stuck in that trap. Everything is pushing you toward the big guys because that's how everyone does hiring. All the HR people, they don't know and not to denigrate HR people, but if they knew the tech, they would be working in tech for the most part. There's a few examples of HR people. I won't say that as a blanket thing. There are some good HR people, but most of them would be working in tech if they actually knew the tech. There was that awesome thing on Twitter. I don't know if you saw the guy. He's like, well, I just interviewed for a job. I forget which tech it was, some new thing. And he's like, I guess I won't get the job. They need like 10 years experience. He's like, but I only have 3.5 years experience with this. And I'm its creator.
Yeah, I did see that.
So anyway, the HR people ask for what they know. What they know is what the reps from Amazon and Google and everyone tell them. Oh, here's the certs. Here's this thing. Just look for these things. Look for AWS certified. Look for whatever Google's certs are, et cetera. And so even though people know, some of us anyway, that you shouldn't be putting all your eggs in one basket, as it were, there's so many things conspiring to make you do that, like you said, until someone gets really bit. And hopefully they get bit when they sit that bill where they're not in so deep that there's no way for them to get off of that vendor without completely losing, like just shutting down the company. If you think about having to do a complete rebuild of all your infrastructure, if you've been in operation for 5 or 10 years, you probably don't have that kind of cash. You probably do not have the time to do a complete rebuild. You basically have to get all your engineers, get an equal amount of them, and then maintain the existing stuff and build the new stuff at the same time. Oh, by the way, you're going to be pissing off all your engineers. They don't want to be maintaining the crap that's all old and crusty that they're stuck with. They want to be playing with the new stuff. So they're going to be pissed that they're stuck doing this when this new team of guys gets to make good, clean, awesome stuff. And then they're also going to be worried because then once you're done with the transition, they're not going to know if you're going to keep them around because they don't know the new stuff. They only knew the old stuff. So they're probably going to get let go. Like, there's a ton of reasons why once you get vendor lock, it's really easy to do that. You're probably screwed. Unless you notice a year or two in, you are probably screwed at that point.
I think two things are going to control some of that vendor lock, or two things are going to help people rethink that vendor lock, especially over the coming years. One is budgets. I think budgets are going to drive it. The other thing I think is going to drive it is data sovereignty. We're seeing more and more countries say, our data will not leave our country, period, end of story. And oh, by the way, we're going to go to the extent of only citizens from our country may be accessing that data. So you put it here or else. And I think between those two things, you're going to see a lot of people go, wow, I can't get benefit from some of this anymore. I'm going to have to rethink and retool how I do this.
Yeah, I wish the data sovereignty, I wish we would see that extend to not just the country where the data resides, but I wish we would see that extend to like the machines. Like, do you have it on your machines? Do you have it on machines you have control over? And that's, I think, the missing piece is that everyone's okay. Like the Palladium initiative, which I think was what it was called. If anyone remembers different, who's more Microsoft-y, like correct me. But Microsoft pitched this back in like, was the late 90s, early 2000s. They're like, hey, why don't you put all your stuff on our servers? It'll be great. You'll never have to install any software. All your docs will be wherever you need them. It'll be awesome. Like they basically pitched the cloud a decade and a half early. And the problem was a lot of people back then are like, wait a minute. All my data, all the code, it's all on your computers. They're like, yeah, it's going to be great. Wait a minute. What if I don't pay? What if I miss a payment? What if something happens? And, oh, well, you'll have to pay us or you won't get access. And so we just said, no, that's ridiculous. Why would I put myself in that position to be completely at the mercy of an outside vendor? And fast forward to today where everything is on the cloud and everyone is exactly in that position.
Yep. And, it's getting worse. We talked about backups and, backup to the cloud. You get into that same position of now your data is going to be held hostage. You didn't pay to get it back out. And, Glacier is a good example. Very cheap going in, bringing it back out. Boy, there's a check.
Oh, yeah. Well, to be fair, I mean, that's how they advertise Glacier.
Yes, they do.
But most people don't realize they know it's asymmetric. I mean, Glacier should be your tertiary or probably quaternary solution for data. It should be more of an insurance plan than an actual major part of your backup system. But the asymmetry is insane.
We've got about 17 minutes left.
Okay.
So I think we got about time for two more questions, which I think are interesting. So let's see what we can do there. I'm going to skip over my light. There we go. My artificial intelligence light management switch just triggered. So we're going to skip that question. So cybersecurity will be transparent to the end user by 2040.
Well, I mean, we're both laughing, but so here I will say, I will be contrarian and say maybe, because what I think is going to happen, what I think we're well into is I think right now we are seeing a shift. We're seeing a spike, like exponential growth in cybersecurity issues. So what I think is going to happen is at some point, probably well before 2040, we will see just a failing of the economics of business. If you use computers to do business, it will get to the point where when you connect a computer to the internet, it will almost immediately it won't be yours anymore. And you'll have multiple different, and this is the problem with cybercrime is you're in a bad neighborhood. Like in normal crime, if you're in a bad neighborhood, you're in one bad neighborhood. But when you're on the internet, you're in all the bad neighborhoods at the same time. So just because you just got slammed by ransomware doesn't mean that's not going to happen by another group and another group and another group and another group. It's not like, oh, you're fine for a while, you paid the protection money. Everyone from all over the globe wants the protection money. So it'll get to a point where the costs, and the thing that we're leaving out of the discussion right now, everyone looks at what's the cost of a breach, what's the cost of remediation, all this fun stuff. But what we're leaving out is the cost of all the tools to try to mitigate. How much are you paying for cyber insurance? How much are you paying for the firewall? How much are you paying for the active scanning? How much are you paying for the red teamers? It just goes on and on. They keep inventing new services because the base layer is broken. The base layer is horrifically insecure. And it will get to a point where, unless you're like Apple and you're making like 60% margins, how are you going to make money? You will not be able to make money after you've paid for all the ransoms and all the security vendors. There won't be anything left over to actually put back into the business. And one of two things is going to happen. We're going to finally move to, building systems properly like we should have been all along, because, oh, it's too expensive, it's too slow. Okay, just wait till cybercrime gets so expensive you can't even touch computers. So we'll either have a major tech lash, as they were calling it, where everyone will be like, you know what, we're done with this, we're going back to paper. Yes, it's slower, but we can actually conduct business successfully and make a profit and not get extorted by everyone all over the world. When's the last time you saw someone go in with a hand truck and walk out with an entire file cabinet full of files? And that's one file cabinet. For even a small business, that's not even a fraction of the files they have. And you can totally go in remotely and pull all of the data, an entire database over the internet. So that speed, that reduction of friction that we get, that's really nice in some ways, is really expensive in other ways. And it's getting worse, I would argue, exponentially. And so within the next probably 5 years tops, it's going to get to a point that we're going to have to fix it, or we're going to go back to paper. And people have kind of brushed that off in the past as, no, seriously, pay attention to the news. I think Erik is probably in a better position than most in terms of understanding the frequency of events. So what would you say to that, Erik?
I would say that the events they're getting larger, they're getting more costly. More records are becoming involved in most events. And I think what's happened is that the dollar amount that an incident costs is being, for lack of better terms, buried. Okay, I think people say, well, it really didn't cost us this much, or they time bound the event. They go, well, it only cost us this much, when they're not really looking at the true picture. Okay, it took more than that. You now have to provide, protection for identity theft for those people that lost their records for, let's say, the next 3 years. And how much is that? And when you start adding things up, those numbers start getting very large. And the savings that you got by rushing to market, whether that be in cloud or not, I think evaporate very quickly. But I think one of the items that happens is that, and I'm going to use the word loss, gets put into a different bucket and never compared back to, the savings that we're going to get from this. And if people were to do that on a more regular basis, I think what they'd find is that most of the savings get undone with the first, if not second, event that occurs. So you're not saving anything. And it's because in some cases, it's because we're not opting to put in the correct security or enough security day one. Instead, we'll do just enough to get it over the line, and we'll come back later and fix it. That's something I hear a lot from people is, we'll come back and fix it later. Well, later never comes. So, do I think that, going back to our original statement here, do I think that we're going to see to where these types of things are, transparent to the end user and they don't have to think about them anymore? No, I think that they're going to become different. I think we're going to see, I would call it an evolution. I think that you're going to, the back end mechanics are going to get hidden, but the user will still have the front end of the checkboxes and there'll be little pretty slide bars or what have you, but the users will still be involved with it. Click here, how much risk do you want to take? Slide this bar. And then the back end mechanics are all completely hidden from them. But do I see it to where they get to bow out of it completely? No, I don't see that.
So, yeah, I think I don't know in a 20-year time frame, but I think there's definitely an opportunity to make it transparent, because one of the things, we have all this training, don't click that link, and all these phishing campaigns, which are, I think, honestly pretty messed up, because you're paying those people to sit there and open emails and click on links and read attachments. That's what they get paid for. So they have to do that, and they're not always going to get it right. At some point, they're going to click on the wrong link. Training can help them click fewer of those less often, but fundamentally, that's what they get paid to do. They're never going to stop doing that. And links were designed to be clicked. So to me, what's insane is that clicking on one link, just one little, like installing software takes multiple steps. How is clicking one link able to actually go ahead and make your computer completely under the control of someone across the world? And I know I can actually explain how, but I'm saying rhetorically, like, that's insane. That is a horrifically designed system. That shouldn't be possible. And there has been a fair amount of research, a lot of it classified, but some of it now is starting to be re-examined in a unclassified scenario, context. So if you look at Australia did SEL4, so SEL4, which is a fully hardened microkernel. And again, going back to the microkernel, there's these trends that keep coming around and again and again and again, and maybe someday catch on. And one of those, you look at virtualization. Sun had that, and the idea of a microkernel, which is basically a better type of virtualization, I would argue, is if you have an OS that's just the bare minimum that runs ring 0, that does all of the management of resources, memory and other resources, processor time, etc., that's small enough where you can formally verify it and make sure it's basically bug free. And then once you're now only exposing virtualized memory, stuff that you have some control over, to all the other programs, you can have much stronger isolation once you're sitting it on top of verified software. So you got SEL4, you got Certicos that NSF funded. The SATC thing is still open to the tune of 53 million right now. There's still research going on. Ironsides in Ada Spark came out recently. It's a DNS resolver that's fully formally verified in Ada Spark. So this is an area, and this is the one thing where I will say, thank you, cryptocurrency. Even though I hate cryptocurrency with a burning passion, the one thing that it's made people do is when you can't upgrade, when all you can do is put code out there and you can't upgrade a smart contract, when you have a bug, you lose hundreds of millions of dollars. Ouch. So you have to be like, since you have no option to upgrade a smart contract, there's been a lot more research into how do you make sure the code is 100% solid when you ship it, because you can't go back and you can't rely on just pushing updates every week, every day, whatever. You have to get it right the first time. And so there has been a nice little resurgence, partly due to cryptocurrency, on like correct by construction code. So that if we move to some of that, it's not going to solve all our problems. There still are human factors, but a big part of it is the systems don't work very well. There's a whole bunch of pointy edges you got to watch out for, and you make one wrong move, click one wrong link, and it's game over. And we need defense in depth on, like, within the system too, not just on the network.
Right. And I think one of the things going along the code avenue, just real briefly, that's going to help us is the whole concept of no code or low code, where people are, honestly, coding will become, similar to Scratch. I'm going to drag this module, into my quote unquote application. I'm going to make these connectors and I'm going to drag the next module in. If those modules are built in a secure fashion and vetted, I'll add that little caveat
They
into
get
it.
there, but yes.
Okay. Now all of a sudden developers, because let's be honest, a lot of developers, they're not trained in security. They don't even, if they get security at all, it's maybe a semester among all their, it's not even a semester. It's a couple of weeks, if they're lucky, in their coding classes on how to code securely. So I think the next generation that we're starting to see the signs of no code and low code may be an interesting twist on that to help reduce some of that. Although, again, there's a lot of devil in the details.
Well, I would say that probably will help to some degree. What I'm even more excited about, I actually did a dive the other day, well, a few weeks ago. And so there's a thing called Synquid that I think I've mentioned in the group before. It's one of the most extreme examples of full program synthesis. Turns out there's a heck of a lot of work in partial program synthesis. And once we finally get to it, this will probably take decades, but once, well, for the full program, I'm talking probably 30, 40 years minimum. For partial synthesis, we're seeing that now, and we're seeing some really interesting work where you can actually fill out a function signature with holes in it where parts are unspecified. And there's like the framework of what it's basically supposed to do. And there's 3 different papers I read. One is deep learning based. The other 2 are symbolic, and I forget the other one. It will look at the holes. It'll look at what you're trying to do. And in a lot of cases, it can autocomplete very complicated code and just be like, okay, here you go. Here's what that algorithm needs to look like. And so as we move to program synthesis, that helps a little bit. But what really helps is when you can start doing stuff in like Idris and you can specify a really tight set of constraints. And this is what Synquid does, is you say, here's the system, here's the logical proof of the system I need. And then the computer just gives you the code for that. And when I say just gives you, it does this big, really expensive evolutionary search, which is why we have to figure out how to scale that, which is a huge task. But when we move away from people just writing code and we move to people specifying what a system should do mathematically, and then let the computer fill in the blanks, we're in a very different place. We're not just kind of haphazardly just slap it together, see if it compiles, see if it kind of does the thing once or twice. We're now at a place where we have mathematically, like, what does this need to do? We're getting a lot closer to engineering like architecture, where we can do finite element analysis and say, okay, cool, this beam has 50 stories on top of it. Therefore, this beam needs to be able to take this much flex, this much static loading, this much dynamic loading, et cetera. Like, someday we will get there with software. We're not there yet. It's probably going to take a little while, but there's a heck of a lot of research going on right now. So I think we can get there. I think that's going to be really cool. That's also why I roll my eyes a little bit when people are like, we should teach every kid to code. I'm like, hopefully that's not a profession in 50 years. So
yeah, we got 5 minutes left. We got one topic I thought was interesting. We're probably certainly not going to be able to do it justice, but why not just throw it up there? So just to tee it up, and I might want to rephrase it, the problem of anonymity on the internet, do we need to solve it? Because right now, of course, anybody that's got an IP address is anonymous at the IP layer. Well, sort of. If they're accessing a server, they've got SSL cert, so you have some confidence you're talking to a server that's owned by maybe some company. And if you're coming from a certain errand block, you know maybe what ISP or who owns that block. But and then there's know your customers. So there's a lot of stuff happening at the application layer that's validating what who the players are in the communication channel. But there's still a strong degree of anonymity, especially on private platforms like Facebook, social media. You can easily create an account and you are in no way held accountable to who you are, what you say. How are we going to solve that problem? That's the question.
It sounds like there's 2 questions there, but let me put one quick thing in. So I think there's an asymmetry in anonymity right now. I think if you get a message from some random person as an average internet user, even somewhat above average, someone who's not resourced, who doesn't have connections to certain groups, governments, et cetera, good luck figuring out who the heck that was. If they take even vague precautions, you will never know who they are. If you're a government that has access to billions of dollars worth of compute and intelligence agencies, and you can subpoena or otherwise get data from these systems, it's very hard to stay anonymous. There are some technologies that make it easier, but I think there's an asymmetry there. If large orgs and governments want to know who you are, unless you're really, really, really good, they're going to find out. But as the average person, you have no way of knowing who the heck is contacting you in many cases. And TLS is a joke. I don't think I need to go on that. Just there's already been so many cases of compromised keys and just so many different ways around TLS. So
definitely
go ahead, Eric.
Eric on that.
So I don't think it's a problem that needs to be solved. I think it's, why do I need to solve the anonymous problem? I don't trust an IP. More and more people are working towards zero trust. I don't trust an IP. I don't trust a machine. I can spoof an IP address. I can jump out a VPN at a different endpoint and become whoever I want. If I'm going to do bad things, I'm going to take precautions. Everything from, fine, I'll go to the coffee shop and use their wireless. Ha ha ha! Now track me down. It's not a battle worth fighting, in my opinion. You will always have various degrees of capability of being anonymous on the internet, unless, God forbid, we're all behind like the Great Firewall of China. And I think that that would pose a whole different set of, problems if that was to become the norm throughout the internet.
Isn't the Earn It Act up for a vote soon?
Yeah, I think it is. I don't
There
see.
you go.
I don't see it happening though.
Let's hope.
Yeah, let's hope. But I don't see. So I don't see, the problem of the Great Firewall China popping up everywhere, because that would, like I said, trigger a whole different set of problems. But even if it did, even if the Great Firewall China popped up, again, these things, like we just talked a little bit about with cloud computing, they're so large, they're so enormous, they're so complicated that, the more complicated a system is, and we've said this time and time again, the more likely it is to have holes, vulnerabilities, things it hasn't, didn't think of, the whole 9 yards. People will find a way. Humans are really creative animals. I cannot build a secure solution that a human can never defeat, because we're just such a crazy type of animal. We will find a way to break it one way or the other. So, it may slow us down for a period of time, but we'd overcome it. That said, I don't think it's a problem that needs to be solved. I want to know who exactly said this to me on Twitter because I'm offended. Well, you know what? There's this real easy button. It's called log off. Just stop looking at Twitter. You're really upset? Delete your account,
Well, yeah. I mean, assuming it's just something that pissed you off, assuming it's not like an actual tangible threat. So, yeah, I think this, because we're running out of time, I think this deserves a whole nother discussion. And like I said before, LaTanya Sweeney's research, I think people dramatically underestimate how powerful recorrelation, even before deep learning, Jesus, some of the tooling now to recorrelate data from multiple sources, mind-blowing. So I'll leave it there.
But yeah, just looking at some of the attacks for where they're doing timing attacks through stuff going in and out of Tor gateways. Amazing
Well,
stuff.
the timing attacks, the one that blows my mind is they're doing attacks with jitter. They are measuring and extracting keys over the wire, where the jitter on the wire is, I think, like 20 to 30 milliseconds. And the timing they need to do the key extraction is like microseconds. I think microseconds, not quite nanoseconds. And somehow with jitter that's several order magnitude larger, they are able to do key extraction over the wire. Like side channel research in the past 5 years absolutely exploded. It's incredible how much you can pull out of the air and other medium.
Yep. And all you have to do is go on to any one of the open source intelligent forums, even if the one simple one on Reddit, and just look at what people are reversing. Being anonymous is very difficult. Can it be done? Yes. But, it's one of those things you're really going to want to need to be anonymous. And the corollary is true. Somebody who wants to find you is really going to want to find you. You'd have to do something very bad or cost somebody a lot of money for them to go through all the trouble. Otherwise, it's just not worth it.
Yeah.
I mean, it kind of goes back to what I say about like APT actors. Oh, the threat hunt has determined that this is an APT actor operating out of Russia. Okay, congratulations. What are you going to do about that?
Yeah. Yeah, it's like I said, there's some asymmetry there. There's really, it depends on, I guess it really depends on both ends. How sophisticated is the person trying to stay anonymous, and how sophisticated is the person hunting them down? But really, like stuff like Freenet is fascinating because they've studied this, their whole threat model. There was a really interesting blog post on freenetproject.org where you were talking about Tor, which has had some notable vulnerabilities where you can, if you own a lot of the nodes, then you can actually do timing attacks and look at TTLs and stuff. And this police department's like, we figured out how to find out who's using Freenet to do nasty things. And we're using like TTL triangulation. And Freenet has a wonderful blog post where they're like, that's cute. That's cute. They're like, we've been doing this for like 20 years and that's our threat model. Like we thought about nation state actors who would have the ability to own the majority of the nodes in the network, which is why we do probabilistic decrementation of TTLs. And here's the real math you have to do. And here's the actual amount of accuracy, which is not very much because we designed the system to inject this much jitter and uncertainty so that you couldn't do this. But cool. Glad one of your interns at the police department thought they could figure this out. So anyway, there's, like I said, I guess what I want to know if we pick this up in the future is, are you asking about the technical aspects, John? of anonymity, or are you asking about the moral and legal implications of anonymity?
Not the technical. I've heard an interesting theory a while back, which said if everybody on the internet was not anonymous and totally accountable for what what their actions did and said, things would be a lot different. Well, first of all, the internet wouldn't have exploded in popularity because a lot of it is due to the anonymity. A lot of people like that. But the question is, are the people that are abusing anonymity, are their voices louder than the rest of the people that would otherwise be good citizens on the internet?
The problem I see with that is amplification. It's not that their voices are louder, it's that their voices they create an amplification through the number of repeats and other things. I see that on Twitter a lot.
And we should also be careful about defining terms here, because there's actually 3 terms. There's anonymity, pseudonymity, and then full authentication. And I see that confused a lot. Like I see that with Bitcoin. People are like, it's anonymous. No, it is most definitely not anonymous. It is pseudonymous. And that can be similar enough to anonymous, but it turns out it's not that hard. There's been a number of cases where they've correlated the key, the wallet, to the actual person. And once that happens, it's definitely you, because that's an actual cryptographic key. It's definitely you that got that money and did that stuff and bought that thing. And that's the downside of that immutable ledger, is like, that's in the record forever. You were, went on there and bought drugs. Everyone knows forever, once that key correlates to you, that you bought drugs on the dark web. So anyway, pseudonymity, I think pseudonymity and authenticated communication are super valuable. I think we are lacking right now. I think most digital identity is owned by third parties. There's very little of it you own yourself, unless you're setting up like a one of the little cloud, like Nextcloud or some of these. Your identity is a combination of what Amazon has on you, what Facebook has on you, what Google has on you, like the login to each one of those, which they can revoke at any time. And I think that, as interesting as the anonymity question is, I think what really needs to happen is we need strong identity. That'll solve a lot of problems. We can do interesting stuff once we have real identity that we just can't do right now. And occasionally pseudonymity is nice. I don't know if anonymity itself is ever super useful, but pseudonymity, if you can keep it uncorrelated, is extremely useful.
So, thank you. That's the question. If we remove anonymity from the internet, is that going to make the internet better or worse?
I think it'll shrink to nothingness. I think people will go away. They're not going to want that. You have just now developed a net that is useful for those things where I have to be positively identified, such as, I'm going to go pay my bills to this place or that place. But social, you'll watch all the social stuff flee to whatever is going to be internet version 2.0.
We've seen the opposite, though. There have been some interesting articles, and I've seen that mirror just in my personal interactions, where people are moving off of Facebook and some of these more open forums, and Facebook's not a great example for anonymity, but Reddit and all these, and they're moving to like Signal and to WhatsApp and to these closed platforms where you do generally know who all the people are in the group. I really think that anonymity doesn't add a whole lot. I think pseudonymity, if you have self-sovereign identity where you can just create a new account, create a new identity that's not linked to anything, I think that's incredibly useful, because most of the stuff that's not nefarious that you want to talk about, you might want a pseudonym so you can keep a long-standing discussion going, and you might not, hopefully you never have it linked back to you for privacy, but you're going to want, like, anonymity means you can't link anything, and that makes it hard to have much of any kind of conversation. All you can do is inject some noise. There are very things you can do with anonymity that are good that you can't do with pseudonymity that's better, that gives you more options, so long as you're careful not to let it get linked back to you. So I think it's a distinction that people need to look at that a little more carefully and look at the implications. So the short answer is, yeah, I think if you got rid of anonymity, but you have to keep pseudonymity without correlation as best you can. I think the internet can still be incredibly useful, probably more so than it is now. If you get rid of pseudonymity and everything has to be fully authenticated all the time, that's not good. That's really bad.
So I think again, this is a good topic for, a much longer time period. I think the challenge is that pseudonymity, because you can potentially correlate back with some of the issues that we've seen over the years, I think you're going to see a drive. And again, it'll be interesting to see if it comes about. People are going to want more true anonymity, to be more truly anonymous than they are now, because they don't want that connection. And if they don't get that, then I think, again, people will go off onto other environments.
But here's the thing. I think the distinction between anonymity and pseudonymity is thinner than you think, because there are ways of analyzing, even before GPT-3, it's relatively simple to do analysis on text. And so if you post more than a few words, there's a fairly high chance that you will get linked back. Again, if it's someone wants to know who's an agency or someone with some skills, they can look at what IP you posted from. They can trace, where the connections came from. Unless you're really good, that's not going to be that hard. If you're really good, they can still look at what you wrote, and they can look at, does that correlate to other writing? If they have some vague idea of who you are, there are already ways of correlating and reconnecting that, even if it's anonymous. And the difference between pseudonymity and anonymity is, again, a pseudonym, you can have long-standing conversations. Like, this is how you get rid of spam. Is you develop an identity over time. You develop trust over time, which is impossible with anonymity. So that's how group security and trust works, is you have to be able to have that trust cure over time, which requires a long-standing identity. And this is why we see so much BS on the internet, is because every identity you run into is equally equal. They're all the same. They're all just as legitimate. And there's no way to say, wait a minute, that thing just got stood up. You're kind of seeing that with social accounts. We're like, oh, wow, look at all these like Twitter users that just popped up like right before this thing we're voting on. There's like 20,000 new users and they're all brand new. And like, there's nothing here. They don't have any account history. Of course, with GPT-3 and some of the stuff now, it's really easy to generate false pictures, generate false profiles. And so that falls apart. So again, going back to identity, you need to be able to generate an identity. It should be self-sovereign, meaning you generate your identity cryptographically. You don't rely on some outside party, not a company, not the state, not anyone else. You generate the key, and that becomes your anchor for that identity. And we'll omit all the complications of key hierarchies and all that kind of junk right now. But you generate that, and then that key can or cannot be linked to other identities. And you can use that to store data, to move data, to have conversations. And over time, as you interact with other identities, you build a web of trust, and you can now evaluate like which of these nodes, which of these identities are actually trustworthy, because you can't do that right now. All we got is big companies that are supposedly identifying, oh, this guy's trustworthy because we say he is. Okay.
Well, and what you've just described is the old PGP key signing parties.
Exactly.
Okay. I don't know if
exactly.
Back in the day, that's what we used to do, is we'd get together and I met somebody in person and I talked to them and said, yep, I'm going to have you associate with me. Here's my disk with my PGP key. Can you countersign it? And that's how it worked. It was the web of trust. I mean, what you're describing is effectively, which is interesting, we're talking about going back to something that existed that we moved away from, like some of us moved away from, back to something that's already known to be good, because,
well, the one part that's not good is the usability sucks. Like, just to be fully brutally honest, PGP and GPG, they suck. Even if you're a dev, an experienced dev, there's a decent chance you will mess up setting up PGP the first time.
Oh yeah.
So we've got to figure out, that's kind of why it hasn't caught on, is we have to figure out, how do we get the usability so people can use it? Because if they can't use it, they're not going to. And identity is one of those things to an extreme degree where network effects are critical. The more people you have using it, the more and more and more useful it gets. And so this is also why a company will never solve this problem. The only way this problem is going to get solved is open source or government research, because a company is going to try to make it so you got to pay, you got to have lock-in, and that means not everyone's going to use it. And that means you've limited the network effect. And even if somehow they do mandate it and everyone in the world is using it and paying that company, that has a whole other set of problems. So it's got to be an open protocol that ideally there are multiple software implementations. But until that exists, like there's a lot of problems we just can't address at all. You need that trust anchor. You need to have that ability to have a long running identity to build trust over time. And you can do some really cool stuff from security and otherwise once you can do that. We just don't have that tooling right now. So, but like I said, I think self-sovereign with pseudonymity, I think gives you all the advantages that people think anonymity gives you without the disadvantages.
Okay.
This
Well, I
is one that we could have a whole longer discussion on.
I just gonna
Love
say a
to.
bunch of new questions popped up this whole last hour. So maybe we'll get some feedback from the group and do this again in another format. Cool. And Eric, Elio mentioned that he had some slides. So if you're willing to share those, we could even incorporate that into the recording and post it on YouTube or save it for another day, either
Okay.
way.
Yeah, I have a whole bunch of fun pictures of stuff that Norman doors and stuff that's just unusable. Some of it's art, some of it's real life examples. But yeah, that was slightly different thing we touched on a little bit. So I might save those.
Well, let's save that because this wasn't tied.
So I really want to focus on, is it the people that are the biggest problem in security? I really disagree with Eric on that. So
Without people, I'd have a really safe, secure system.
You also, why would you even have a system?
Well,
No
that's
the AIs can talk to
different
each other.
story.
To be continued.
Okay. So we recorded this. We'll post it on YouTube after we get it cleaned up. And then, cool. My only goal was to do a little better than Chris Wallace. So hopefully I'm not that standard. Perfect. That's it. I'm going to check out. We've got 42 people left, but so great meeting, a lot of participation, and yeah, reach out if you have ideas on other topics. We're looking for speakers and presenters. So even if you've never presented before, if you've got a compelling topic, don't be afraid to raise your hand, and we'll see if it's of interest to the group, right? So that's it. Thank you,
Thank you,
everybody,
John.
for
Thanks, John.
joining.
Thanks,
Great
everyone.
meeting.
Thanks, Eric.